Okay, welcome to the session. So today we will be discussing the topic of the load balancing. So before starting the load balancing, okay, let me start this. Okay, let me open my Paint window also. Okay. So whenever coming to the load balancing. So what is the main term meaning by load balancing is so whatever the thing that is coming to any endpoint or everything, the traffic should be distributed equally. So let's say. So let us consider. Okay. So let us consider you are maintaining some network site. So one application. So in this application, there will be large number of requests that is coming to this application. Let's say if there is an application like techmethods.com. So techmethods.com. So then let's say this application or let's say you're having a flipkart.com. So generally there will be many users that will be trying to purchase many applications from the Flipkart sites. So to in order to purchase these applications, every user there will be n number of users. So this n number of users will be simultaneously hitting the application at a time. So what happens is the load should be out. If there is a large load hitting on this application at a one time, so what happens is the load will be high on this application, and it will not be able to handle this load. So let's say from one region, okay, let's say I consider it as a region. So let's say 1,000 requests are coming from this region, and in the second region there are around 200 requests are coming from this region. Let's say 2,000, and here if there are 3,000 requests are coming to this from this region, but your application will be handling only at a time it handles around 4,000 requests. 4,000 requests, or let's say it can handle, but if in your application what is happening is, let's say there are 3 VMs. Okay, so these 3 VMs, each VM can handle around, let's say here total there are 6, so 3 VMs, or each VM can handle around 2,000 requests at a time. So what happens is, so at it should there should be some mechanism that should be handled so that all these requests should be routed accordingly to the each VMs. So first VM should if all the 6,000 requests are hitting to the first VM, then what happens is my application will be crashing. Okay. Yeah, sorry for that. Okay, let me see whether it is recording. Okay, it's recording. Okay, let's say there are 3 VMs for me. So in these 3 VMs, what is happening is there are one from one region, let's say East US. There is one location like East US, and then it is coming 1,000 requests from West US. You are getting around 2,000 requests from let's say India location. You are getting around 3,000 requests. Vamsi, can you place this link in this WhatsApp chat? Meanwhile, I think Jalebi is asking for the link. Maybe.
Sure.
Okay. Okay. So from India, there are around 3,000 requests. So what is happening is this request should be handled by the application in a mechanism such that it should be handled in a safe and secure manner, and so that the application should not crash. So what I have discussed till now is there are around 3 VMs for my application, and each VM has a capacity to handle only 2,000 requests at once. So how I should place a mechanism like if 1,000 requests are coming to this, route to VM1. If next 2,000 requests are coming, it should route only the remaining 1,000 requests to VM1, and the remaining out of 2,000 it will be remaining 1,000 requests, it should route to VM2. So and then it will be handling 3,000 requests, it will route the 1,000 to the VM2 and VM3. Okay, I will draw these things so that it will be easy for your understanding. So this is my VM1. So VM1 can take around 2,000 requests. So what will happen here is, So the first 2000 will go to VM1, and the next out of 1000 will go to VM2, and the similar way we will be having a one more VM here. So in this one more VM, what happens is that the 1000 will go to VM2. In this 3000, 1000 will go to VM2, and the last remaining one more VM I have. In this VM, the remaining 2000 that are coming request from the India location, that will go to VM3. So this is happening. This mechanism should be there in the setup, so that this request will be routed automatically. But my question is how? How we should have this mechanism in place? So the answer here will come here is there are two types of things. The important concepts are load balancer, load balancer, and one more thing is application gateway. So these are the two important resources that Azure is providing, so that it will automatically take care of this routing and everything. So first we will today I will be going through the theory concept of the load balancing. So tomorrow we will be going through the practical scenario, lab scenario. Then we will be taking the application gateway. So coming to the load balancer, okay, as I have till now in the example what we have discussed is how to manage the load from few specific regions. Okay, sorry, someone is trying to speak. Okay, the represent. Okay, okay. Now I will try to give one more example. So consider one. This is the railway station. Okay, as today I have come across. Okay, so there are n number of trains will be coming into the station, and then it will be leaving to the station. So there will be few dedicated. I mean, in railway station there will be platform so that the train can enter and leave this. So how the railway department will be managing all the things is they will be having some mechanism like if any train is entering to the station, they will be dedicated one platform to that, and then the train will be moving to that, and then it will I mean it is like a you consider train as a traffic. The traffic will be going to the your system is nothing but your railway station platform. So whatever the traffic that is coming from the outside, it will be passing into the system, and then based on the routing methods you have said. Routing method here is nothing but the instructions that is given by the station master. Consider this is the station master. I will give here as a station master here, station master, and consider this is my station, railway station, and consider this is my platform. P1 is nothing but platform 1, P2 is nothing but platform 2, and P3 is nothing but my platform 3. So if there are four trains, if there, I mean, let's say any train is coming into the station or anywhere. So what happens is before coming to it will be coming through your station master who is there responsible for that. So he will be routing the traffic. Traffic is nothing but your train to the respective uh, what is the platform that is waiting. It is empty. So here also you consider like if first he will route to platform 1, and then if it is platform 1 is filled, now he is the chance to route to platform 2. So platform 2 is filled, now he will route to platform 3. So as the platform 1 station, the train passengers are on board in the train, then the train will be leaving out of the station. Now what happens is platform 1 will be vacant, then the request will come to the platform 1. So what here it is happening is first the request will be coming to the first platform, and then second, and then third. Again it is following a round sequence of the same manner. It is nothing but it is called as a round robin method. So round robin method is the inbuilt technology that is following by the load balancer. So this is nothing but round robin method. So round robin method is nothing but first it will allocate to the first instance, and then second instance, third instance. If suppose there are n instances, it will be allocating 1, 2, 3, and so on n. And after that, all the instances are allocated, and then it will sorry guys, and then it will allocate it to the first instance again. So it is like a following a round robin method, and it will allocate the traffic. Allocate is nothing but it will route the traffic to the whatever the instance that is available for the free at that time, particular time. So this is the concept of how the round robin method is following. Now we will be going to the pure concept of what is a load balancer. So before that I have PPT ready for this. Let me go walk to the PPT. Okay. So coming to the load balancer is nothing but it is how the load will be distributed and balanced across your application. Coming to the load balancer. Okay. Let me go into the point of view. Okay. So load balancer is nothing but it delivers high availability and network performance to your applications. As you have seen in the railway station example, so the passenger should not be in a trouble and they should be highly available is nothing but the train should be come to the respective time that have dedicated and they should be onboarded to the train. In the similar way, whatever the application that you are working, the end user should be highly available and there should not be any network latency issues that should be faced by them. So in order to serve all these things and the parameters, the load balancer is the correct right solution that is provided by the Azure team. The load balancer distributes inbound traffic to the backend resources using load balancing rules and health probes. Okay, what is this backend, front end, rules, and everything we will be discussing in the upcoming 5 to 10 minutes. We'll go going there. And load balancing rules determine how traffic is distributed to the backend. Health probes ensure the sources in the backend are healthy. Okay, first we have here main important concept we should come to is front end. Front end is nothing but from where the load is coming, and back end pool is nothing but to whom it should be distributed. How this happens front end to back end, it will be definitely happen with the help of the load balancer here. So this is the symbol of the load balancer. And in order to carry this operation successfully and smoothly, there will be having a load balancing rules. So based on the rules that you have specified, the load balancing will be happened to the backend pool. And there is a here concept of health probes. Health probes are nothing but it will initiate a dummy command. Like suppose if you wanted to check any status of your suppose if your internet is coming or not, what you will do, you will go to the you will go to open your Google Chrome here. Let's say I will go my Google Chrome, and this in Google Chrome what I will type. Okay, so here I will go here. In Google Chrome I will type like a speed test. Speed test is nothing but what you are trying to think how fast is your internet is responding. So this is a plugin that is provided by the Google. So if you click on this run speed test, what happens is it will send you packets. So some bits of data will be sending to the through this tool to the internet, and it will test how much speed your internet is coming. In the similar way, health probes also has those similar type of things that will be acting in that are provided by the load balancer, and it will perform a check with your backend how fast the data is transmitting and how fast the data is coming. Data transmission and coming here in the sense from load balancer to the backend and from backend to the load balancer. So health probe is nothing but a probe that will check whether your backend is healthy or not. Suppose in the backend I have placed 3 missions here. So in these 3 missions, whether these missions are correctly allocated or not, or it is underutilized. So this is like a health probe. I will try to give this example in the railway station example. Okay, consider the station master here. So station master will have health probes also here. What is health probes is whether the platform is vacant or not. First he will create one health probe with the P1, P2 and P3. He will check in the P1 health probe whether station is vacant or not. If the station is vacant, then he will allocate the train to this platform number 1. So in the similar way, whether P2 health probe is working, then it will send us the message like P2 is vacant, or platform 2 is still not vacant, passengers are onboarding the train. Like that, it will send a communication between your station master and the railway station. In the similarly, from the load balancer to your backend pool, in the backend pool, whether you are hosting your application or the VM, anything it matters. So health probes will give a link between your load balancer to the backend. So and coming to load balancer can be used for inbound and outbound scenarios and scale up to millions of TCP and UCP application flows. Already we have discussed on TCP and UDP. It is nothing but the data interaction that is happening from the load balancer to the backend. So these scenarios can be achieved with the help of the load balancer. And coming to the types. So what are the different types of the load balancer? There are 2 types of the load balancers. One is public and one more thing is internal. So as you can see from the name itself, public is nothing but it is available over the internet. You can assume like that. Whereas internal is it is somewhere it is masked and it is not available over the internet. Like it is not exposed to the outside world. Like that you can think as of now. When you deep dive here, we will understand these things. Okay. Now we will discuss on what is the public load balancer. Okay. Okay. So public load balancer is nothing but public load balancer maps the public IP address and port number of the incoming traffic to the private IP address and port number of the VM. Okay. So what happens here is I'll try to okay. Here only I'll explain what is happening. So already we have discussed in the previous classes like how to create a VM and how to place the VM into the subnet. So those are all the concepts we have discussed. So generally, if you create a VM, what we have done, we have tried to expose that through the private IP address only. We did not give the public IP address because it will be exposed over the internet. So now what we will do is we will place all the VMs in the private, I mean in one subnet, and we will be accessing through the private address only. But to access them we should give some address to the public is nothing but it should be accessed over the internet. Now what we will be doing here is we will create a load balancer. In the load balancer we will attach it to the public IP address. What will happen is people will be able to hit this load balancer through the public IP address. But what happens in turn in the back end is it will convert the public, it will get the response based on this public IP, and it will route to the private IP. So it's simple, what you will understand is in the front end you are facing it over public IP. So you are exposing your load balancer, I mean you are trying to hit your traffic through the public IP, whereas in the back end it will automatically hit through your private IP. How this transaction will happen is through your load balancer. So that is the same point we have mentioned here. So this is your private IP. Okay. So a public load balancer maps the public IP address and port number of incoming traffic. That is nothing but what are the traffic that you are initiating to the private IP address and port number of your VM, respective VM. So that is the same we have mentioned here. So mapping is also provided for the response traffic from the VM. So this mapping will be also done to know the response traffic. And by applying the load balancing rules you can distribute specific type of traffic across multiple service and VMs. So if you apply this load balancer you can distribute the traffic. How you will be distributing the traffic is based on the round robin method. So first the traffic will be going to the VM1, and then it will go to VM2, and then it will going to VM3. So it will follow in the round robin method and this sequential manner. So as you can see in the diagram, it shows like, so internet client sending web page request to the public IP address of a web port on TCP port 80. Azure load balancer distributes the traffic across 3 VMs in the load balance set. Okay, how here the traffic is getting initiated is it is initiating from the internet. Let's say I will hit my application like techwizards.com. Okay, I will how I will be hitting here is, okay, let's say here it is my, okay, consider this is my load balancer, and what I'm doing is this is my internet here, and in the back end here I have placed 3 VMs, 1 2 3 VMs. Okay, so this is my load balancer. I'll take it as LB, and this is my internet here, and then this is my VM, and this is my VM1, VM2, and here VM3. So now what happens is, so if I wanted to access the application, so what he will do, he will open his in Google in his mobile, and then he will try to hit this IP. So here instead of providing this VM's IP, what we will be providing here is, let's say the VM IP is, it is like a private IP 10 dot, what I'm doing is 1.0.0 uh, okay dot 5, so let's say 11. So and here what I'm giving of my second IP is 10.2.0.11, and okay, something I'll put some other IP like 22, some random IP I'm taking. So let us assume these are all the private IPs. So 10.3.0.33, let's say. So now for instead of exposing these IPs to the outside world, what we will be doing is we will create a for this load balancer we will be initiating a public IP. So public IP will be like something like 162.238.10.74. Okay, let's say some IP will be like this. So what he will be doing is from to the outside world, in case if Sai opens this and he wanted to hit the application, what he will do? Let's say this DNS name I have provided like DNS is nothing but the what is the domain specific name that we are using here. HTTPS colon double slash tech with us.com. This is the DNS name that I have provided for this public IP address. So now if Sai wants to hit this application, you can do in two ways. One is through the IP 162.238.10.74. Now I have exposed this over my port 80. So he will hit like this. If he hit this application, he will be able to access. Or else he can do in the same way like this also. HTTPS colon double slash techvitas.com .com port 80. So if he hit like this also, he will be able to access the same application. But now what is happening is, suppose there are four persons. Let's say Sai has hit this application. First Sai will be he will be routed to this VM1. So he will be access this application with the help of VM1, but he doesn't know through which on which VM is able to access. Ultimately, he should be able to access his application. Okay, after some time, Vinay has tried to access, and then he will be routed. As first Sai is allocated here, he will be routed to the second VM now, because second VM is available now. And if Dilip is trying to try to access his application, he will be going to VM3. Now, if a fourth user is coming, suppose Vamsi is trying to hit the application, he will be going to the VM1 again. So based on the load that VM1 will be taking, but the outside URL will be exposed like 162.238 and 74 colon 80. That is nothing but our here public IP address of a load balancer. So this is like public load balancer. What we are discussing till now. Whereas coming to the internal load balancer, so as you can immediately known from the naming convention, public is nothing but it is all available over the internet. Whereas coming to the internal load balancer, it is following some secured way. But how it is following some secured way, we will discuss now. So coming to the internal load balancer, it redirects the traffic to the resources. The same thing it is performing, but that are inside the virtual network. So what here is happening here is, we are creating some virtual network, and in the virtual network, if you wanted to route this traffic and everything, you can use your internal load balancer. So that is the main purpose of difference between those two things. So if you wanted to expose to the outside world, then you can go with public load balancer. Whereas if you wanted to go and route your traffic that are placed under your virtual networks or some secured resources mechanisms, then you can go with your internal load balancer. So and there are some examples like if they are present under the virtual network, or that uses an VPN to access your Azure infrastructure. Let's say you suppose Infosys, consider Infosys application. So Infosys is in a network. So in that, what happens is, you cannot access your Infosys application from the outside world. So what you should do is, you should connect your VPN. So when you are connected to your VPN, then only you can able to access this network. So at that time also, you can use this internal load balancer to manage the traffic that are connected through the VPNs. So those things also we can be managed here. And then front-end IP addresses and virtual networks are never directly exposed to the internal endpoint. So, and one more thing is, as they are in a very secure manner, they will be not exposed to the any internal endpoints, or any internal line of business runs in Azure are accessed from within the Azure or from on-premises resources. So, for example, an internal load balancer could receive data request that needed to be distributed to your backend Azure SQL servers. So, this is one type of example that are trying to propagate here. And coming to the internal load balancer enables the following type of load balancing. So nothing but within a virtual network. So from within a virtual network, how you are able to route the traffic. And from cross premises virtual network also, you can use this internal load balancer. So if you wanted to have a multi-tier application, so if you wanted to have a multi-tier application, when the backend tiers are not internet specific, then you can use the internet this internal load balancer. Okay, I will try to give an example here. Multi-tier network is nothing but, okay, okay, you tell me which load balancer I need to place at what place. Okay, I'm asking a question, you try to answer based on this discussion we have. So this is my internet search engine. So this is my internet is nothing but the outside one, internet search engine. So what I'm doing is, I should hit some applications. Let's say I have 3 virtual machines. This is VM1, VM2, and VM3. So what I have done is, uh, I have created all these VMs under a virtual network, one secure virtual network. I have created all these things, all these VMs. So in VMs, each VM should be hitting to 2 SQL databases. So I will draw here one SQL database. Okay, only first VM is hitting some SQL database, I shall assume. Now I wanted to create a load balancer here. So what I will do is I will create one load balancer here. Okay. Okay, I will create one more load balancer here. So what happens is here, whatever the request that is coming from the internet, it will hit here load balancer first here. It will route to the VM1 here, and then it will route to VM2, and then it will route to VM3. And from VM1, the request will be coming to one more load balancer here. It will hit to SQL database, and it will hit to SQL database. Okay, now I will just name here. This is nothing but VM1, VM2. Here I am placing my VM3. But here, this is instead of VMs, here I'm fitting here SQL database one as SQL one, and here I'm placing SQL. Okay. Now my question is, okay, I will change some color here. Okay, let us assume it's black color. Okay. So, which this green color is which type of load balancer, and black color is which type of load balancer? If you try to, if you followed, just you can answer.
Green color is like public load balancer, and black one is like internal load balancer.
Perfect, perfect. Yeah, that's correct. So now, why we are trying to keep here is as all the VMs and SQL databases are inside my virtual network. So as I have created a virtual network, so all these resources that I am placing are inside my virtual network. So we can use here internal load balancer here. So I can place here internal LB, whereas this all the VMs that are trying to expose to the internal internet, I can use my public load balancer here. Okay, perfect. Here public load balancer I can utilize. So hope you have understand the difference what public and internal is behaving like. So this is nothing but a multi-tier application. This is this architecture. Okay, for multi-tier. This is architecture is nothing but multi-tier application because all the applications that are will be present under a VNet only. But you will be having some some address or URS that should be outside exposed to your outside world like Flipkart.com, Amazon.com, TechWizard.com like that. So if you wanted to expose those things, you will be using some load balancer. So for Azure, we have load balancer, but there will be so many things like front door, and then there will be having application gateways. So based on the needs and scenarios, we can discuss all the things. The application also will be taking the right suggestions there. Okay, great, you understand these things. Now coming to the load balancer SKUs. So whenever you are trying to create a load balancer, you will be having you will be selecting the type of I mean whether it is internal or public load balancer. You will also select the SKUs. So SKUs is nothing but it will be specifying, it will be having the features accordingly. So there will be two types of SKUs. One is basic SKU and basic and standard. So each will be having a different set of features based on the types of options that you are opted for. So the standard load balancer is a newer load balancer product with a expanded and more granular features set over a basic load balancer. So when I was taking a courses, we have only basic load balancers, but now they have come up with a new load balancer like standard load balancer. So it is nothing but it is having some extra privileges coming to the basic load balancer. So you can see from the here statement like it is a superset of basic load balancer. So it is covering all the basic load balancer aspects as well as some more additional features. So we will discuss some few capabilities that some quick comparison between basic and standard. We will take 1 or 2 minutes here and then we'll move forward. So these are all the backend pools, help groups which we have discussed. So coming to the backend pools, how many instances you can host with a basic SKU? So using the basic SKU, you can take around 300 instances you can host. Whereas coming to the standard, you can go with 1,000 instances. And what are the health proofs? What is the actions you can make? HTTP, TCP, you can actions you can make. Whereas using these standard things, you can make a secure way of calling your backend proofs, backend pools with the help of these health proofs that you have taken. And coming to the availability zones, there is no option. There is no option of availability zones here. Whereas in standard, you can go with geo redundant and zonal front end for incoming and outbound traffic. And multiple functions are inbound only. Here, inbound and outbound both are handled in the standard SKU. And coming by secure by default, here you can having by open by default NSG optional. You will be having the both the things here. And coming to the SLA, you can set like what is the percentage you can choose. But in SKU, we are not having any SLA metric. Whereas is coming to the standard, you will be choosing the 99.99% SLA here also. So if beyond that, if any downtime is happening, Azure will be paying for the same for you. And if you wanted to create any load balancer, you can go to the load balancer here, and then you can select the type, create load balancer, and you can choose a resource group, and you will be having an option to select the SKU here, whether it is a standard and basic, and what is the type of load balancer, public or internal, and tier, whether it is regional or global. So this is the load balancer, how the SKUs will be there. And now we will be discussing on the backend pools. So backend pools, by this time, if you have understand what is a front end, back end, and load balancer, just simple. Backend pool is nothing but where all the traffic will be routed for. It is, you can assume like it is a target of your load balancer. Whereas front end is like in where is it is like a destination. Sorry, where your traffic will be reached. Whereas source is like from where it is emerging. The traffic is simple. Now we will be discussing about the backend pools. So coming to the backend pools. So to distribute the traffic, a backend address pool contains the IP address of the virtual NICs that are connected to the load balancer. How you configure the backend pools depends on whether you are using standard or basic SKUs. So based on the types of metrics that you have taken, whether it is standard tier or a basic tier, you can define your backend pools the similar way. Coming to the backend endpoints. So in standard SKUs, what you can do is any virtual machine in single virtual network, or you can use a blend of virtual machines availability sets and virtual machine scale sets. You can use all the things at the same time. I mean, you can take the virtual machines, you can take the availability sets, or you can use the virtual machine scale sets. Coming to the basic things, we can use any one availability set or one virtual machine scale set at a single time. So this is the main standard differences between the standard and basic SKU. And coming to the backend pools are configured from the backend pool availability blade. If you open the load balancer, as soon as you create the load balancer, in the left side section, you will be having the backend pools. So in these backend pools, you can create your backend. I mean, what is the backend pool you have? If you can create, and you can attach your virtual network or VMs under it. So and then, as we have already discussed, in standard SKU, you can have up to 1,000 instances in the backend pool, whereas in basic SKU, you have having your 300 instances. When we go through this lab and everything, you will be understanding exactly how to configure a load balancer, how to configure a front end, how to configure a back end accordingly. And load balancing rules. So you can specify what is the type of net traffic you can send to your backend. So based on the rules you have specified, that will block your traffic or you can allow your traffic. So as you can see here, load balancer, a load balancer rule defines how traffic is distributed to the backend pool. So what are the type of traffic you wanted to allow, you can allow. Let's say same, consider the railway station example. So in the railway station example, suppose there is a normal ordinary train and there is an express train. So what the station master will decide is, he can halt the local train for some time and he can give the way to the express train. In the similar way, if there are two applications or two users that are trying to hit, if there are two networks, let's say one is following some high paid network and someone is using low paid network. So what generally they will be application will be trying to do, we can create a rule. So if the request is coming from the high paid network, then you can allow it first, and then the request that is coming from the low paid network, you can allow the later. So like that, the set of rules you can define. So how you can set these priorities and everything, as we have already discussed in the NAT rules. So 100 will be the highest priority, 101 is the next priority, like that. So we have set the priority. We can set that actions also based on the priority rules. So load balancer rules defines how traffic is distributed to the backend pool. The rule maps this rule maps a front end IP, a port combination to set a backend IP address and port combination. So it is like the rule what it will taking all the parameters is front end IP it will take and port, and then it set into backend IP and port. So by configuring the rule, create the front end, back end, and health loop. This okay. The diagram shows a rule front end TCP connections to set a back end web ports. Okay, you can see in the diagram like in the left side load balancing rule section. If you navigate here, you will be having an add option here. If you click on this add option, you can specify the name, what is the type of IP version, and then you can specify the front end IP address, and you can select the backend pool. So and you can see what is the type of interaction that you want, either it is TCP or UDP, and what is the port number you wanted to host. I mean, it is specifying, and backend port, health probe. If you create any health probe, you can map that health probe here. And what is session persistence? Okay, session persistence also specifies how a traffic from your client should be handled. That is one also important thing. Like, so you can we will discussing that later also here. So after specifying all the parameters, you can create your load balancing rule. So based on this load balancing, whenever a traffic is originating from that particular IP address, it will automatically route the traffic to the particular destination backend pool. So you need not to wait till to which pool I should be mapping and those things. Okay, I will give an example here. I'll go into my paint window. Okay, let's say in VM1, VM1 is having an IP address of 10.0. Okay, 1.0 dot 11. Okay, so and then here my backend pool is here is this is a SQL pool. This consider this is a SQL pool, and then if I having a SQL one IP address also, let's say 10 dot, let's say to 5.0 dot 55. That's it. This is my IP. Now I can create one load balance rule here. What is the rule that I can create? Okay, if any traffic, okay, I'll click on add rule and then I can give like front end IP. So front end IP I will give here 10 dot, okay, 1.0.11 and then backend pool name. So in the backend pool I can specify here SQL pool. So and then I can give like backend IP. So if they are asking, so backend IP I can provide like 10.5.0.55 and then whether how it is a connection TCP or UDP connection. If I wanted to have any health probe, so if you have already created any health probe, you can attach the health probe here. Okay, like yes, and you can give the name, specific name of the health probe, and then you can give all the parameters and click on the add rule. Now what happens is if any request, okay, let's say I'm trying to send one request here. So from internet someone is trying to send a request here. This request has reached the public IP and from public load balancer it hit the VM1. So as soon as it hit the VM1, this rule will come into action, and then based on this rule it will automatically send the request to the SQL pool 1. It will not wait to which VMI to which backend pool I should redirect. So because as already rule is present here, it will take the request from source and it will send it to the destination based on this rule. So this is why load balancing rules are very effective. Okay, so we have discussed those things. Okay, coming to the health probe.
Yeah.
Yes.
One second.
Yeah.
So if the rule is not, if we are not adding a rule,
Okay.
so will that be, waiting in the queue and according to the SQL pool, it will allocate to the some SQL pool according to that,
Yeah, yeah.
or
It will
how come
allocate
it is?
automatically. So the request will come here to the in load balancer. So load balancer based on the round robin method, it might reallocate to SQL1 or it will allocate to SQL2. It will not wait. Okay, it will be very quick actually. It will be
No, if
maximum.
the rule is not mentioned, if we didn't add a rule,
Okay.
so how it will happen? For sure, we need to add a rule,
Yeah, if you see, if you wanted to route the traffic that is
right?
coming from VM1 and some set of instructions, so it should automatically route to SQL1, then you will be adding the rule. Or else it will automatically route to 1 or 2 based on the round robin methods. It will
Okay.
automatically take care. Okay, great. And then coming to the health probe. What the health probe mainly will do is it will monitor the status of your app. As I have said before, see in your registration, if the station master will be sitting at one place and whereas
Oh,
platform will be at some other place. Now what he should know, there should be some communication between the station master and the platform, like whether the platform is empty or not and those things. So for this there will be a connection like some health probe. So using that health probe he will check whether the platform is empty or not, like that. So this is just an example. Now I will try to relate it with the real world scenario. So real world scenario is nothing but you will be having your application. So let's say you have hosted your application. uh, okay, I will give an example that will be very good actually. Okay, I'll give here itself. Okay, now what happens is there are three virtual machines here. Okay, consider this example. There are three virtual machines. So what I have done is I have installed my three versions of my application. Okay, same application I have installed in three machines because it should be available. So I have installed on VM1, VM2, and VM3. So what happens is here. So whenever suppose there are 10 users. Okay, what it will do first, it will come first request will come from the internet. So public copy, public load balancer, and it will send to one, and he will able to access his application. Okay, here he will be able to access his application and he will be able to enjoy the services of application, and then he will go to VM2 and then we will be VM3. Now what happens is after some time there are there are no users hitting this application. So what happens is no active instances will be present there. So during these times, might be the application one might be as it is inactive, it might go to the hung state or everything. So how it will manage is, it will use the health probes here. So with the help of this health probes, it will check the whether application status is active or not. It is like a check. It is a check pointer. So it will check the point first VM, and it will check the second VM. It will check the third VM, whether all these VMs are actively running or not. So if there is, suppose let's say VM1, VM2 health probe is working fine, VM3 health probe is not working fine. What happens is, it will deallocate this VM. Okay, deallocate this VM is nothing but it will cancel this VM3 for now, and it will send the request only from VM1 and VM2 until unless if you go and fix the issue manually. So what happens is, if so, now here what it will think is, there are only two VMs for me, I should serve the request only from VM1 and VM2. That intelligence will be automatically balanced by the load balancer. So it will send request from VM1 and VM2, it will send request, and VM3 will not send request because health probe is not active. Now what we will do? We will go to the Azure portal and we will fix those health probe, and then we will, once the health probe is fixed, health probe is nothing but the VM got reboot or something we will be doing from the backend, and once the VM is available, this health probe will be active. So then the request, it will serve the request to backend VM3 also. So this is how the mechanism will be working. Hope you are clear. So that is why health probe is very important. As you can see, health probe allows the load balancer to monitor the status of your app. The health probe dynamically adds or removes your VM from the load balancer rotation based on the response to your health checks. As just now we have discussed. Now, as we have discussed VM1, VM2 and VM3, as I said, as health probe is not active, VM3 mission will be automatically removed, and then VM1 and VM2 will be available in the backend pool. So once we go and fix the issue in the VM3, VM3 will be automatically get added back to the backend pool, and it will serve the request to the three VMs. Hope you are clear on that concept. Okay. When a probe fails to respond, the load balancer stops sending new connections to the unhealthy instance. So as we discussed, so if the probe itself is not responding, it will not send a request to the that unhealthy instance. It will send only to the healthy instances. So there are two main ways to configure health probes. Whether you can do some HTTP or you can use the TCP. What is the difference between the HTTP and TCP is, the load balancer regularly probes your sorry. Okay, when you use the HTTP custom probe, what it will do is, it for every 15 seconds it will hit the target what in the backend pool, whether the target is responding correctly or not. The session is healthy if it responds with the HTTP 2000 within the timeout period. So what happens is, for every 15 seconds it will send a request, and by default within 30 seconds it should send a HTTP of 220 request. Then only it will consider like the status is active. Any status other than HTTP 200 causes the plop to failure. You can specify the port URL for requesting the health status from backend, the amount of time between the probe, the number of failures that for the instance to be considered unhealthy. Okay. Now I'll explain here in the diagram. Okay. I'll try to explain here. So consider this is my load balancer, and I'll try to draw my backend pool here. So in the backend pool, I will try to create two instances. One, two. Okay, two instances I am trying to create here. So now what I will do is, from the load balancer, I will send a request to the VM1. I mean, it is nothing but health probe. I have created two health probe connections. This is both are HTTP connections I have created. Give me a second, guys. Okay. Okay. Sorry for the disruption. Okay. You're able to hear me, right? Hello.
Yes, sir.
Okay, fine. So, okay, as we are discussing the health probe thing, now what I have done is, I have created a load balancer here, and then in the backend pool, what I have done is, I have created two VMs here. This is nothing but BP backend pool, and here I have created VM1, and then I have created my VM2 here. So now coming to the health probe, what I have done is, I have created two health probes. So for VM1, I have created one health probe, and I have done it as a HTTP connection, and then from VM2, I have created one more health probe, and it's a HTTP connection. So when you choose a HTTP connection, what it will by default, what the action will be performing here is, So it will try to send the request for every 15 seconds. So first request will send for every 15 seconds, and then simultaneously it will send the request for 15 seconds for this. So after sending the request for every 15 seconds, it will wait for 30 seconds to get a response. So it will wait for 30 seconds to get a response. The response should be 200 error. See, sorry, 200. Sorry, 200 is nothing but correct. It is responding correctly. From similarly, it will try to expect 200 response from the VM2. If suppose VM1 is responding fine, but VM2 is not responding fine, then what happens is it will deallocate the VM2 and it will send request only to the VM1. So it will mark VM2 as an unhealthy instance. So it is nothing but it will not it will consider this as an unhealthy instance, and it will not send any request to the VM1. So how this is happening is it will happen with the help of the health probes only. Okay, hope you are clear on that. I will move forward. Okay. Whereas coming to the TCS probe, TCS probe relies on the establishing a successful TCP connection to the defined port. If the specified listener on the VM exists, the probe succeeds. If the connection is refused, the probe fails. You can specify the, okay, it is nothing but if you establish a connection at once, it will automatically check it as a successful, and the probe will be succeeded only. And if the connection is refused, suppose if the connection is not able to establish, it will consider refuse. Which is the most intelligence way of connection is HTTP custom probably, because for every seconds it will initiate a connection and it will test whether it is working fine or not. So this is the health probe. So this is coming to this what is the lab scenario. Tomorrow we will be discussing on this lab scenario. So how to create a how to create a connection, how to establish a load balancer. So this is my load balancer here. So I am trying to create a load balancer. So whenever I am sending a request, how it is sending the request to this VMs, and how it is pairing. So as we have discussed on the pairing concept also we have done, and I have created one more load balancer here. So how this load balancer is communicating to the other VMs. So all the things we will be discussing. So by these things, you will be understanding at high level how the load balancer is working, and how the pairing will be done in, and how we have created a subnet and VNet. So tomorrow we'll be discussing on this lab activity. So if you are having any queries, you can ask me, or else we will wind up the session for today. Hope you have got an understanding of what is a load balancer, what is a front end pool, what is a back end pool, what is a health probe, what it defines exactly. I think we have limited
Yeah,
amount of
we'll
time.
get an idea, complete scenario in a lab session
Yes,
for
yes,
sure, I
yeah,
think.
yeah, sure. So, and you guys keep practicing also on the scenarios that we are discussed. So, listening is like fine, but what is the thing is you will get a confidence when you start practicing. So, try to put your efforts in practicing. Then, if you are having any queries, also you can come up with the queries. We will try to address them. Me and Vamsi will be available. We will be try to address them. Okay, guys. Thank you so much for joining the session. We'll meet tomorrow, same time.